Welcome to the first of another three-part series of video lessons. These video lessons will be covering our factor label method and how we convert like units. This first lesson will look at just metric to metric unit conversions. When we talk about the factor label method, this is the only acceptable method for completing unit conversions here at the STEM Academy. This will be expected not only in this class, but will be expected in all of your other science classes and in some of your math classes as you move forward. So the sooner you learn this, the better off you'll be as you make your way through your time here. So let's look at our first example. Our first example is to determine the equivalent of 427 centimeters in meters. Now, there is a specific process that we'll go through, and again, it'll follow along very similar with the guess method that we've used previously. The first thing we need to do is determine what we know and what we're trying to find. We know that we're given 427 centimeters as a distance, and we know that we are then trying to figure what that is in meters. So the first step here is I'm going to write down what I know, and then I'm going to begin to multiply this. Each time I'm going to multiply this by a fraction. Now, these fractions are used to cancel out units. So if I have 427 centimeters in the numerator of my first portion, I'm going to want to have centimeters in my denominator in the other portion to cancel that out. So I'll put 100 centimeters down the bottom. And the reason I want 100 centimeters is because I'm going to use the relationship of 1 meter equal to 100 centimeters. So now I'm able to cancel out my centimeters. And then all I do is multiply all the way across the top and all the way across the bottom. So I have 427 times 1 gives me 427 meters divided by 100. Remember, it's just 100 because my centimeters canceled out. I'll then move forward dividing that. So 427 meters divided by 100 leaves me with 4.27 meters. So that's a really basic example of how we can use the factor label method here, or dimensional analysis as it's also called, to convert from one form of unit to another. Let's look at another example. This time we're going to look at mass, and we're going to determine the equivalent number of grams to 1.47 kilograms. So again, I write down what I know, and I write down what I'm trying to find, or where I'm trying to get to. So again, I start out, I write out where I want, or where I'm starting with 1.47 kilograms. Then I'm going to multiply by some fraction. Now, I'm looking at kilograms, I want to get to grams, so I can use my relationships page, or my relationship sheet, to determine what's the best way to do that. Well, 1 kilo is equal to 1,000 grams, or 1,000 standard units. So I'm going to put my 1,000, I'm going to put my 1 kilogram at the bottom. That'll allow me to cancel out kilograms. And I'm going to put my 1,000 standard units, or my 1,000 grams, up top. So again, kilograms cancel out. I'm going to multiply across the top, multiply across the bottom. So I have 1,470 grams divided by 1. And that should be some quick, easy mental math for you to find out that I have 1,470 grams equal to 1.47 kilograms. Now, these are two fairly routine, fairly basic examples. They can get a little bit more complicated when you get into hectometers or hectos, decas and decis and millis. Your numbers can begin to move around a little bit, but remember, they're still all based on 10, so it shouldn't be too terribly difficult if you're using your relationship sheet. Let's move on to our third example. Our third example is going to be our first rate example. A rate example is an example that has some form of time used in it, and specifically time in the denominator. So here, let's look at it. We have a tank, and it's leaking at a rate of 11.5 milliliters per second. How many liters are being leaked each minute? So our question is phrased a little bit differently here. It's a little bit of a step up from where we started. So I'm given that I have 11.5 milliliters per second leaking out of the tank. but I'm trying to find how many liters per minute are going to be leaked out of the tank. Okay, possibly a more useful means to look at it. So I start out with my 11.5 milliliters, and when I have per, that word per represents division, so I have 1 second there in the bottom. So 11.5 milliliters per second looks mathematically as if it is 11.5 milliliters divided by 1 second. Now, I'm trying to get to liters per minute, so the first thing that I'm going to do is I'm going to convert my milliliters into liters. To do that, again, I come back, I take a look at that relationship sheet, I see that I have 1,000 millis in one standard unit. The standard unit would be our liter. So I put my 1,000 milliliters down in the denominator, I put my 1 liter up in the numerator, and that'll allow me to cancel out milliliters. But that now leaves me with liters per second, so I have to do another step. This isn't necessarily just a one-step process, this can be a multi-step process. So now I need to move from seconds to minutes. Now, you won't find this on your relationship sheet because this is hopefully something that's a little bit more intuitive for you. Right? We look into our minds and we find out that we have 60 seconds in 1 minute. So if I want to cancel out seconds, I have to put 60 seconds in the numerator and then follow that with 1 minute there in the denominator, and my seconds cancel out. So the only units that I have left that haven't been canceled out are liters and minutes. And if I look back in my unknown, that's exactly what I want to find is liters per minute. So again, now I multiply all the way across the top, take 11.5 times 60, and then I'm going to multiply all the way across the bottom, which will end up being 1,000, and I'm left with 690 liters divided by 1,000 minutes. Now I want to make sure that I reduce that, or reduce the numbers there, so that I'm left with 0.69 liters per 1 minute. So this is your first rate problem. And our last example here for today is going to be a second rate problem. We're going to look specifically here at a car that's traveling at 5.94 kilometers per hour and determine how fast it's moving in meters per second. We're going to use meters per second a lot in this course, so we want to make sure that we can get from more publicly known quantities such as kilometers per hour into some of the quantities that we like to use because they just work a little bit better with units and math. So I'm again given my rate of 5.94 kilometers per hour. I'm told my unknown that I'm trying to get that into meters per second. So I start with my 5.94, and remember it's per hour, so I divide that by 1 hour. And now I need to begin to convert from one unit to another. I'm going to start with my unit on top. I'm going to start with kilometers. I know that there, in 1 kilo there are 1,000 standard units, and for this we're using meters as our standard unit, so I'm going to put 1 kilometer down in the bottom of my fraction and 1,000 meters up in the top. That'll allow me to cancel out kilometers. So now I'm left with meters. So I don't have to do anything else with my distances. Now all I have to do is make some changes with my time. So next step, I need to get from hours to seconds. And I'm going to do this in a two-step process. I'm going to go from hours to minutes and then from minutes to seconds. So we have to think for ourselves, how many minutes are there in 1 hour? There's 60 of them. But I want to cancel out hours. So I cancel out hours by putting hours up top and my 60 minutes down there at the bottom. Cancel out hours. Now I'm in meters per minute. Again, not necessarily where I want to be, so I've got to go from minutes to seconds. Again, I go back to my personal experiences. I've got 60 seconds in 1 minute, so I'm going to put my 1 minute up top, 60 seconds down there in the bottom. At this point, now that I've canceled minutes, the only two units that I have left are meters and seconds, and that's exactly what I want to see. It's kind of a nice double check when all of your units kind of cancel out and you're left with exactly what you want to find. So I multiply all the way across the top, all the way across the bottom, and I'm left with 5,940 meters divided by 3,600 seconds. I reduce that to find that my actual rate here in meters per second is 1.65 meters per second. Don't be afraid to go back and watch the video, pause it where you need to, but also please, please, please make sure that you ask questions of your instructor when they come up.